Hi everyone, welcome to this next video. So in this one I'm just going to go through some fundamentals, some basic things that you need to know if you are sitting the higher paper. So we'll go through some various different areas of the maths curriculum for higher and just things that will help you pick up marks along the way throughout the paper. What I've done is I've put timestamps in the description, so if you want to skip through certain points and you think, yep, I understand that, you can skip that point, skip that part and go to a part that you need to work on. So we're going to start initially here with laws of indices. So hopefully you understand your basic laws of indices, things like 2 to the power of 4 times 2 to the power of 6, for example, would be 2 to the power of 10 because you are adding those. So if you're not 100% sure on your laws of indices with things like that, or if it was x to the power of 8 times x to the power of 7, you add those two together there, which would be x to the power of 15. So hopefully you already know these laws, and then also things like dividing, what you would do with that. If you're not 100% sure, go back and watch my laws of indices video, which I've done as well. I'll put a link to that in the description as well, alongside the other bits. So let's look at these ones though. 64 to the power of a half. So if you have an indice that is a fraction, what you need to do is you need to first of all think about using a root sign. So the first thing you do is you see a fractional indice, you put a root sign, you put the number underneath it, whatever the denominator is falls to the outside. So think about it like that. So the denominator falls to the outside of the root sign, and then you're going to work that bit out first, and then whatever answer you then get from there, you will then use your numerator as your power. So first of all, so effectively, I'm doing the square root of 64. So I work that out, and then because the power, the numerator is 1, I will then put it to the power of 1. So this would be square root of 64, which is 8, and then 8 to the power of 1 is 8. So 64 to the power of a half is just 8. So let me show you another example. So if you had something like this, let's go for 125 to the power of 2/3. Same thing, you do your square root sign. The denominator is now 3, so you 3 on the outside. 125 goes underneath it. So you work that bit out first, and then we're going to square our answer afterwards because there's a 2 at the top this time. So the cube root of 125, what times by itself? 3 times give you 125, which is 5, and then 5 squared, which is 25. Okay, so that's fractional indices. It's worth knowing that, making sure you can get your head around it, making sure you're happy with it. Let's look at what happens with a negative. So if I've got a negative, we've got 4 to the power of -2 in this question. What you can do is you can think about it like this. 4 could actually be written as 4 over 1. So what we're actually now saying is we've got 4 over 1 to the power of -2. Now to remove the negative part, we do the inverse. So you flip it upside down, so it becomes 1 over 4 now, and we're squaring that. So by flipping it upside down, it gets rid of that negative part. You don't have to write it in brackets, you could write it like that. But remember, 1 over 4 squared is the same now as doing 1 over 4 times 1 over 4, which is 1 over 16. Okay, so if I show you another example of that, let's just move that up there. Let's do 3 to the power of -3. So put it as 3 over 1. And we're doing 3 over 1 to the power of -3, which is the same thing. Flip it upside down, it becomes 1 over 3. And now it becomes 1 over 3 to the power of 3. So by flipping it upside down, we get rid of that negative. And that just means 1 over 3 times 1 over 3 times 1 over 3. 1 times 1 times 1 is 1, because you're multiplying fractions. And when you're multiplying fractions, you multiply top by top by top, bottom by bottom by bottom. 3 times 3 is 9. 9 times 3 is 27. So that becomes 1 over 27. Okay? That's your negative indices. You could then combine the two, but I suggest what you do is you go back and watch my video on laws of indices if you want to look at that in a little bit more depth. Here, really simple, anything to the power of 0. So this is not a degree sign, it's a power of 0. Anything to the power of 0 will just be 1. Okay, never put your answer as 0. Anything to the power of 0 is 1. Even if I had x to the power of 0, my answer is 1. Okay, 5,624 to the power of 0 is 1. Okay, again, if you want an explanation on why that is the case, In my other video, I explain it. But if you just want to remember, anything to the power of 0 is 1. So then moving on then, the next thing we're going to talk about is surds. So we're going to do quite a bit on surds here. We're going to go through the key things you need to know. It's very much worthwhile understanding surds, getting your head around them, because they do crop up in quite a few different examples. So we're going to go through the basics and then some more complex bits as we work through it. So first of all, we need to know how to simplify a surd. So root 18 is a surd because there is no square root of 18. So what you're trying to think about is what numbers multiply to give me 18 that are square numbers. So square numbers are 1 times 1, which is 1, so there's no point in using that. 2 times 2, which is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. So you're thinking about any of these numbers, whether or not they go into any one of these numbers here. And you're looking at seeing if any one of these numbers go into any one of these numbers here. So 18 is what I've got. What numbers here go into 18? Well, it's really clear there that 9 is what I'm looking for. How many times is 9 going to 18? Well, it's 9 times 2. So now what you're saying is the square root of 9 times 2. Well, there is no square root of 2, but there is a square root of 9. Square root 9, it becomes 3. So 18 becomes 3 root 2. Okay? There's no other number in that list that goes into it. So let's look at the next one. Same thing, root 20. So what we're looking at is what numbers in this list here go into 20. Well, 4 goes into 20. So I can say straight away 4 times 5 gives me 20. Remember, it's square root because we're talking about surds. There is no square root of 5, so I leave that as it is, but there is a square root of 4. The square root of 4 is 2, so that becomes 2 root 5. Last one then, here, you can see that this is maybe a little bit harder because if you go back to this list over here, you can see 4 goes into 48, 16 goes into 48, no others do. So actually what we've got here is a situation where 4 times 12, but also 16 times 3. Now what you want to do is if you have two possibilities, you select the highest one. You select the one that has the highest square number in it. So there is no square root of 3, but there is a square root of 16. The square root of 16 is 4, so that becomes 4 root 3. If I used the 4 times 12, the square root of 4 is 2, that would become 2 root 12. But then 12 can be simplified again because 4 goes into it. So there's no point in doing that because you're going to have to do twice the amount of work. So always choose the highest one. This leads us nicely onto the next part now, which is adding and subtracting. You can only add or subtract surds if they are the same. Okay, so if they are the same value in the surd. So for example, here where I've got 3 root 2, 2 root 5 and 4 root 3, none of those could be added together because the surd is root 3, surd is root 5, the surd is root 2. So you need to make the surds the same. It's a bit like algebra. You can only add them together if it's an x and an x and a y and a y. So let's look at root 8. What number goes into 8? If you want to pause the video and have a look at simplifying them first, you could do that. But if you don't want to and you want to just watch me, that's absolutely fine as well. So the square root of 8, we know that 4 times 2 would be my simplification of that. The square root of 4 is 2, so that comes to the outside, and then it becomes 2 root 2. So root 8 simplifies to 2 root 2. We've already done root 18, and we know it was 9 times 2, square root of 9 times 2. So 9 gets square rooted, it becomes 3 root 2. So now you should be looking at thinking, no, that's great, right? Because I've got root 2 and a root 2, they're the same. So I'm saying 2 root 2 plus 3 root 2, your answer very simply becomes 5 root 2. Imagine it being like this, 2x plus 3x would be 5x, okay? It's exactly the same concept with this. If you didn't have surds that were the same, you couldn't add them. It's exactly like algebra, okay? So let's look at this next example. You could pause the video and maybe have a go at this yourself, but it's a little bit harder because what we've actually got is these values on the outside already, and we need to try and make the surds the same. So we'll talk through this bit now. So root 20, which we already did up here, we know that root 20 became 4 times 5, and we're square rooting that, which is 2 root 5. But we've still got this 4 we need to bring down. So I put the 4 back there, but what you need to remember to do is actually then put a times sign, because this actually means 4 times the square root of 20. So we're saying the square root of 20 becomes 2 root 5, so I need to multiply it by that 4, which means this bit here becomes 8 root 5. So if you already have a number on the outside of the root sign, when you simplify it, whatever you bring to the outside, so square root of 4 was 2, whatever you bring to the outside, you then multiply by what's there. Now you could have a go at doing that for this one. Think about what square number goes into 45, and then bring it down. So if you wanted to have a go now, and pause the video. And so root 45 becomes 9 times 5. Okay, that's the highest square number that goes into it. That's the only square number that goes into it. So what I'm saying is the square root of 9 is 3. So it becomes 3 root 5. And straight away I'm thinking, yep, this looks good because I've got a root 5 there and I've got a root 5 there. So I know they're going to match up. I bring the 2 down. And remember, when I bring the 2 down, I've got to multiply it. So that becomes 2 times 3, which is 6 root 5. Now, 8 root 5, 6 root 5 is the same as doing 8x plus 6x. It would be 14x. So in this case, same thing, but it becomes 14 root 5. Okay, so that's your simplifying, that's your add-in surds if the values are different. So let's now look at multiplying surds. So what happens when we multiply? How does it work? And then we'll look at some expanding brackets as well. Okay, moving on now. So we're going to talk about some more surd stuff. We're going to talk about how we multiply with surds. So whereas the previous bit we've spoken about adding surds, we're now going to talk about multiplying in some different styles that you might get. If you understand the fundamentals of this, then a lot of other stuff opens up and it does make it a little bit easier. So let's jump straight in. Now, in the previous bit where we said you can only add surds together if they're the same, so looking back here, we could only add root 8 and root 18 together when they both had the root 2, right? This is different. So if surds are different, so this is a root 3 and this is a root 5, if they are different, you can very simply just multiply them together. Now, root 3 times root 5 actually just gives you root 15. Okay, so you just times the numbers together and then you put your root sign underneath, over the top of it all. Okay, so root 3 times root 5 is just 3 times 5, which is 15, and then root 15. Now, what you might find is so if you wanted to remove a surd, so if I then do root 3 times root 3, that actually is root 9, and we can work that out. So when you times a surd by itself, it will give you the square root of the number, and the square root of 9 is actually 3. So a surd times by itself basically just gets rid of the surd sign. Okay, but that's why. The other thing you might see is something where you end up having something like root 6 times root 2. So root 6 times root 2 would give you root 12. And thinking about what we know from up here, when we spoke about simplifying, root 12 can be simplified because actually that becomes 4 times 3, and the square root of 4 is 2, so that would become 2 root 3. Okay, so just be conscious. Sometimes if it ends up giving you a number that can be simplified, you need to make sure you do that as well. Let's look at this next example here then on the right. So we've now got a number and a surd, and a number and a surd. So this concept looks a little bit more confusing. However, it's really simple. You still do the surd times the surd. So root 5 times root 2 would give you root 10. So we still multiply those together. And then what you're doing is the numbers. So you're then doing 2 times 3, which is just 6. So the answer to that is actually 6 root 10. Now there's another way I can check that that is right, because what I can actually do is I can reverse this process. I can put this 2 back in there. Okay, so if I was to put the 2 back into that root sign, you square 2 this time, so it becomes 4 times 5. And we do the same thing here, which would become 9 times 2. Okay, so I'm just squaring the outside number and sticking it back in. Now 4 times 5 is 20, so this actually would be root 20, and 9 times 2 is root 18. So what I'm basically saying is, what is 20 times 18? So you could, obviously if you had a calculator, you could work it out. Or what we could do is we could go 18 times 10, which is 180, and then times that by 2 to get 360. Okay, so we know that this would end up giving us root 360. Now, from there, you could then look at this and go, okay, what square number goes into that? Well, 36 times by 10 gives you 360. The square root of 36 is 6, so it becomes 6 root 10. So that's just another way I can prove that I'm getting the same answer if you wanted to double check your working out or your understanding. So that's your fundamentals of multiplying. That's how you'd work out just your basic multiplying here where you've got surds, and then if you have a number on the outside by a surd. Now, if you had a number on the outside, so let's say it was 3 root 7 times root 2, for example, effectively that just becomes 1 root 2. So you still do the same thing. So root 7 times root 2 would give you root 14, and then 3 times 1 is just 3, so that would become 3 root 14. Okay, so let's look now at some expanding with brackets. So if we have brackets involved in it, the concept's exactly the same as what we've just done there. Now, we hopefully know how to expand brackets. We do the outside times the first value and outside times the second value. So this actually just becomes 4 times root 2, which is just 4 root 2, and then 4 times 3, which is 12. So the answer to that would be 4 root 2 plus 12. Okay, so that's your basic level of what we're looking at. Now, if we look at this next one, we've got 2 sets of brackets, so slightly different, because actually what we're doing now is we're looking at that concept of the moon method. So if you don't understand what I mean by moon method, if you check a video I've done on expanding double brackets and factorising quadratics, that's what we're talking about. So we do the first value, so the root 3 times root 12, and remember that's a surd times a surd, so that just becomes root 36. Then I'm going to do the root 3 times 5, which becomes 5 root 3. It's like doing x times 5, which would just be 5x. Okay, then I'm going to do the next value, which is 2 times root 12, which is plus 2 root 12. And straight away now I'm thinking root 12 can be simplified, so I know I'm going to have to do something with that later on. And then the last bit, I'm doing 2 times 5, which is just 10. Now all the signs here are positive, because everything's positive in these. If there's negative involved, you just need to be a little bit careful and make sure you are using those negative signs. So root 36 is 6, and we've also got this 10. Okay, so that actually is going to end up giving me 16, because that's a like term. 6 plus 10 is 16. Now what we need to look at is the fact that, can I simplify this? Well, I can't at the moment, because that's a root 12 and that's a root 3. But I do know that root 12, so I'm just going to come over to the side here. So 2 root 12. I'm going to simplify that root 12, and hopefully from what we looked at before, you understand it's 4 times 3. We've still got this 2 on the outside though. I'm now going to square root 4. The square root of 4 is 2, and I bring it to the outside, and there's already a 2 on the outside, so I multiply it by the 2 that I'm now bringing out as well. So there's already a 2. I square root the 4, bring that on the outside, so that's how I get that second 2. And because there's already a value on the outside, you have to multiply it. So actually that becomes 4 root 3. So that 2 root 12 becomes plus 4 root 3. We bring down the 5 root 3 because we can't simplify that anymore. And now what you can see is they're both root 3s. So you're now saying 5 root 3 plus 4 root 3, which is 9 root 3. That would be my final answer. So the answer to root 3 plus 2 brackets root 12 plus 5 would be 16 plus 9 root 3. Okay, so just following that moon method as normal and following the same rules that we know about multiplying with surds. Okay, last couple of bits on surds. We're going to talk about dividing, and then we'll go on to rationalising. So with dividing, you need to think about it a little bit like this. If it was 10x over 2, your answer would become 5x, right? It's because you just do 10 divided by 2. The answer to this is exactly the same as that concept. So 10 root 5 divided by 2, you're just doing 10 divided by 2, which is 5. And then you do not simplify the root 5. So it stays as root 5. So let's look at another example. Let's say I had 18 root 6 over 3. It'd be really easy for you to think about the fact that you need to do 6 divided by 3 would give you root 2, but you mustn't do that, okay? So 18 divided by 3 we can do. We end up with 6, but the root 6 stays the same. So that would be your answer. Okay, another example, 24 root 5 divided by 6. You could pause the video, have a go at that if you wanted to. Thinking about that, 24 divided by 6 is 4. So your answer would be 4 root 5. Okay, so that's how you divide. Just make sure you don't actually divide the surd. You leave the surd as it is. So moving on now to the last bit about surds, we're going to talk about a bit of rationalising. So we'll go through the basics of rationalising and then look at a slightly more complex example here as well. So basically what you're looking at is rationalising effectively means remove the surd from the bottom of a fraction. Okay, so remove the surd from the bottom of a fraction. That's effectively what a question is asking you to do if you see the word rationalise anywhere, or if you just see a question where there is a surd at the bottom, okay, in any of the questions, just rationalising it will probably pick you up a mark somewhere at least, okay? So in this instance here, I need to basically remove root 5 from the bottom. So if there's just a surd at the bottom, what you do is you multiply it by root 5 over root 5. So because there is a root 5 here, I therefore multiply root 5 by root 5, and as we spoke about previously, when you multiply a surd by itself, it gets rid of the surd sign, because root 5 times root 5 is root 25, and the square root of 25 is 5. Whatever you're doing to the bottom, you must do to the top. So remember, you're multiplying this by root 5, so you've got to multiply the top by root 5. So that therefore effectively becomes 8 root 5 over root 5 times root 5, which is root 25, which therefore simplifies to 8 root 5 over 5. I cannot simplify that anymore because I can't do 8 divided by 5. Okay, so if the question was something like this, if it was 15 root 5, if it was 15 over root 5, then you'd still multiply it by root 5 over root 5. I'd end up with 15 root 5 over root 25, which would then give me 5. And then, as we just spoke about there, 15 divided by 5 would be 3. So that would become 3 root 5 would be your final answer there, okay? So that's if you can divide, like we've just spoken about there, do it. Obviously, if you can't, then leave your answer in its most simplistic form, which is what the answer would be here for this one. So that bottom bit there is all just, let's rub that out, just another example, but that would be your answer for that one. Okay, let's now talk about this second example here. So 3 plus root 2 over root 8 plus 4. First thing I should be thinking here is that root 8 can be simplified. Okay, so you could either simplify it now or you can simplify it at the end. I'm actually going to leave it to the end, and just so I can explain this process to you now. So the difference here between this question and this question, this just had a root 5 at the bottom, whereas this has got a surd and a number. So if you have a question like this, what you actually need to do is multiply it by the opposite. And what I mean by the opposite is the root 8 minus 4. So it becomes root 8 minus 4. So the opposite of the plus 4 becomes minus 4. Now, if the question was this, if it was if it was 3 plus root 2 over 4 plus root 8, then I would multiply that by 4 minus root 8 over 4 minus root 8. Okay, so whatever that second value is there, flip the sign, do the opposite. Okay, and I'll show you why that works now. So going through this, what we're actually doing is we're doing 3 plus root 2 multiplied by root 8 minus 4. Now we've just spoken about how we expand those in a previous bit we did up here. So we're kind of linking back to this concept, which is why it's important that you understand that. And then let's look at the denominator here. We're doing root 8 plus 4 multiplied by root 8 minus 4. So let's go back to our mu method. So let's do the top. 3 times root 8 becomes 3 root 8. 3 times minus 4 is minus 12. Root 2 times root 8 is plus root 16, which we know will give us 4 in a second. And then root 2 times minus 4 is minus 4 root 2. So the top becomes that. Now what we need to do is do the same for the bottom. So root 8 times root 8 is going to be root 64. Root 8 times minus 4 is minus 4 root 8. And then this is why this works. Now we're doing plus 4 root 8. And then 4 times minus 4 is minus 16. So you can see here straight away, minus 4 root 8 plus 4 root 8, they cancel out, okay? And by doing that, we're cancelling them out, which means we're now just left with no surds at the bottom. So let me tidy up each part for you. So let's look at the top here. The root 16 will become 4, so I'm just going to come down here and do this again. So 3 root 8 we'll talk about in a second, minus 12, plus this root 16 becomes plus 4, and then minus 4 root 2. Now, let's go back to what we spoke about before as well. 3 root 8, the root 8 simplifies to 4 times 2. The square root of 4 is 2, so that becomes, so I bring the 4 out, that becomes 2 root 2. But remember, we've still got this 3 here, so because there's already a value there, you have to times it by that, so that becomes 6. So 3 times 2 is 6, 6 root 2. So this part here becomes 6 root 2. This part here is obviously becoming 4. Okay, so the top part of this fraction now actually becomes 6 root 2 minus 12 plus 4 minus 4 root 2. Let me just make a little bit more space here. Okay, let's just rewrite some bits now. So let's take that top part, rewrite it so we've got a bit more space. So now the top part has become 6 root 2 minus 12 plus 4 minus 4 root 2. So that's what the top's become. If we then look at this bottom, so hopefully you know root 64 is 8, and then we can say that this middle part here cancels out. Minus 4 root 8 plus 4 root 8 means I have 0, and then we've got this minus 16, so we know that we're bringing down minus 16 there. So what you're basically doing is 8 minus 16, so the denominator of this fraction actually now becomes minus 8, okay? So you can see by what I've just done there, by actually multiplying this fraction here, the denominator by the opposite, it creates this middle section here and cancels out those two parts, okay? So I end up with 6 root 2 minus 12 plus 4. Let's tidy that up. So if we then go back to the top, minus 12 plus 4 gives me minus 8, so that's quite easy to work out. And then we've got 6 root 2 minus 4 root 2, so we end up having a 2 root 2, okay? So it's basically like doing 6x minus 4x, okay? So minus 12 plus 4 was a minus 8, so that's that bit done. 6 root 2 minus 4 root 2, perfect. And then this is all over minus 8 at the moment. Now, let's just look at that, because we can go a little bit more simplistic. Think to yourself, what does this all divide by? So ignoring the surd bit, what can I divide all of that by? Well, they're all even numbers, so I can divide by 2. So 2 divided by 2 is just 1. And remember, you leave the root 2. Minus 8 divided by 2 is minus 4. And then minus 8 divided by 2 is minus 4. Now, what you don't want is you don't really want a negative at the bottom here. So in order to get the negative, effectively what you would do is times that by minus 1. So if you times it by negative, it turns it to positive. Or you can just think about it in the fact that you actually end up changing all the signs. So where that top bit, instead of putting 1 root 2, I'm just going to put root 2. Where that top bit is a positive root 2, it would become a negative root 2. Where it's a minus 4, it becomes a plus 4. And where it's a negative 4, it becomes a 4 there. Now that looks a bit messy, so I can actually write it the other way around as 4 minus root 2 over 4. That looks a little bit tidier than that version there. Okay, so that's the idea of rationalising. As I say, if you want to know a little bit more about it and you want to get your head around surds more, watch my full video I've done on surds. But they're the real key things that you do need to know, especially if you are on the higher and wanting to get a higher grade. Okay, so definitely worth watching. We'll move on now to the next part of the video. Right, so in this next bit, we're now just going to look at some stuff to do with quadratics. Cannot stress the importance of understanding quadratics and how to use them, how to work them. So we're going to go for a bit of factorising. We'll talk about solving. We'll use the same questions here, and we'll talk about solving. We'll use factorising to solve, quadratic formula to solve as well. And I'll talk you through a couple of bits with these. Okay, if you do want to know more about these, more details, watch the other YouTube video I've done on this, where we go into it in more detail. So remembering that factorising means putting brackets. Okay, really important that you know that. You're basically just kind of simplifying the whole expression. So here we need to look at two numbers that add to your second value and multiply to your last value. Think about it, that it goes AM Okay, so it's easy to remember. It's in the morning, AM. Add to the first number, multiply to the second number. So think to yourself, what adds to 7 and multiplies to minus 18? If you're ever not sure, do your factors for this. Okay, so what multiplies to 18? Well, 1 times 18, 2 times 9, 3 times 6. Nothing else multiplies to give me 18. And you're thinking to yourself, right, out of those numbers, how could I possibly make a 7? Well, I can't possibly make a 7 by adding or subtracting there. Can't make a 7 there because if I added them together, I'd get 9. If I started taking away, I'm going to end up with 3 or minus 3. So I know it's going to be these two pairs. So you put your x in both brackets. You put your 9 and your 2. And now you just need to figure out which one's negative, which one's positive. So I need the numbers to multiply to minus 18. So one will be negative and one will be positive. And I need it to end up adding to this positive 7. So I need a positive 9 because 9 minus 2 gives me positive 7. And 9 times minus 2 will give me my minus 18. Okay, so again, worth practicing. That's a skill. Make sure you just do your factor pairs if you're ever not sure, like I've done there, to get your head around what numbers you could use. Okay, next one here, a little bit harder. The reason that this is harder is because this value in front of x squared is greater than 1. Okay, so the value of x squared is greater than 1. So it's, here it effectively to be a 1, whereas this one we've got, it could be 2, 3, 4, 5, 6, could be anything. Okay, so your first step here is to multiply the first value by the end value. So you're doing 3 times minus 10, which is minus 30. So now what you're looking for is still two numbers that add to give you minus 13, but this time that multiply to give you minus 30. So you're not looking at this multiplying to give you minus 10 anymore. This third value we're actually now using is going to be minus 30. So again, you can say to yourself, right, well, what multiplies to 30? 1 times 30, 2 times 15, 3 times 10, 5 times 6, 7 doesn't, 8 doesn't, 9 doesn't, and then we're back to 10. So they're all my factor pairs of 30. Now what you're thinking is, okay, out of those, how could I possibly make a 13? Well, there's a couple of different ways I could do it here. Look at this. We've got a we've got a 2 and a 15 where I could make 13. And I've also got a 3 and a 10 where I could make 13, right? But you need to think to yourself about the fact that it has to multiply to give you a negative. If it is multiplying to give you a negative, it means only one of the values will be a negative. Okay, so think to yourself about that. One of them could only be a negative. Well, if it was minus 2 and plus 15, 15 minus 2 would be positive 13. So that doesn't work. If it was positive 2 and minus 15, well, 2 minus 15 is minus 13. So that would work for this question. Common one that pupils would put would be this one because I think 3 and 10 makes 13. But to make 13, they would both have to be positive, right? Because 3 plus 10 is 13. Whereas if you had one as positive, one as negative, you're going to end up making a 7 somewhere. So it has to be this 2 and 15. So here's a shortcut for this. Whatever this value is here, you put that in both brackets. So I'm going to put a 3x in the first one, a 3x in the second one. And then the plus 2 goes in one and the minus 15 goes in the other. Now, I know that's not right at the moment because if I do 3x times 3x, I end up with 9x squared, so that doesn't work. So what you now do is you look at which one can be simplified. So which one of these two brackets can I simplify? Well, nothing goes into 3 and 2, but there is a number that goes into 3 and 15. It is 3, so you divide this one by 3. When you divide this one by 3, you end up with x minus 5. I can't divide this one, so I leave this as it is. And at that point, I know I'm factorised, and I know that that is my correct answer. Now, let's look at it, multiply it out, double check myself. 3x squared, 3x times 5, which is minus 15x. 2x, that's a positive 2x. And then 2 times minus 5 is minus 10. Collect my like terms here. Minus 15 plus 2 is minus 13. Still got my 3x squared, minus 10. So when I expand it out, I end up getting the original answer to the question that I had. Okay. So the question is actually only asking you to factorise. So this here, this bit here would be my answer. Okay. So let's now look at how we move on to solving with this. So I've used exactly the same question. So x squared plus 7x minus 18 is the question, but this time it says equals 0. Okay. Now, in order to solve a quadratic, it must equal 0. If it does not equal 0, looking at this example here, you have to make it equal 0, and we'll talk about that in a second. But so there's a couple of ways you can do this. We're going to first talk about factorising. So if you can factorise a quadratic, do it. So here, we know that when I factorise this, it was x plus 9 and x minus 2. So x plus 9, x minus 2. But this time, because we're now solving it, we're not just factorising. So up here, the question just would say factorise, whereas here it's saying solve. You say equals 0. Then what you do is you say each bracket equals 0. So x plus 9 equals 0, or x minus 2 equals 0. And then I take the 9 over, and it becomes x equals minus 9, because you are solving, which means you get an x on its own, or x equals, take that 2 over, positive 2. So these are your two answers for that. Now, the reason that works is because if I was to substitute both of those numbers back into this equation, I would end up getting 0. So let me show you what I mean by that. So let's start with the 2. I change x for 2. So 2 squared plus 7 times 2 minus 18 should give me 0. Well, 2 squared is 4. 7 times 2 is 14. Minus 18. Well, 4 plus 14 is 18, and 18 minus 18 equals 0. So when I work this out as x is equal to 2, it does give me 0. Okay, so that's the 2. Now, if I do exactly the same with the 9, so we say minus 9 squared plus 7 times minus 9, and then minus 18. Well, minus 9 squared is minus 9 times minus 9, which is a positive 81. Okay, really important that you remember when you square a negative number, it becomes positive. Then we're doing 7 times minus 9. Okay, so the key thing to remember here is that you're doing a positive times a negative, which means my answer is going to be negative. So you're doing 7 times 9, which is 63, but it's minus 63. And then minus 18 should give me 0. Well, 81 minus 63 gives me 18. 18 minus 18 is 0. So using 9 as well will also work. Okay, so that's basically what you're doing when you're solving. Now, if we look at this second example here, what we're actually doing is the same process again. So factorising first. We know that it factorised to this, but the difference at the moment is this doesn't equal 0. So if it doesn't equal 0, what you have to do is take the end value over that way. You always want this x squared to be positive, so I'm not going to move that. That at the moment is a positive 10 because there's no sign in front of it. It then moves over this way and becomes minus 10, and it equals 0. So your first step is to always make it equal 0 if it doesn't, and then that will get you a mark in most questions when there's a quadratic involved. And then from there, I'm left with what I had back up here, 3x squared minus 13x minus 10. So 3x squared minus 13x minus 10. You then go through the factorising process here, which we already know is 3x plus 2. And then x minus 5. And then again, we're saying equals 0. At this point, you need to then solve again. So we say this bracket equals 0, so 3x plus 2 equals 0, or x minus 5 equals 0. Okay, so you're again taking your two brackets and making them equal 0, and we are still solving. Now, I'll do the first bit in a second, but let's do this one first. So we take the 5 over, it becomes a plus 5. So we can say one of our answers is x is equal to a positive 5. Here it's going to be a little bit different. We're still going to take this 2 over, but we've got a 3x now. So we're saying 3x is equal to minus 2. And now I need to remove this 3. Well, on that side, that means 3 times x. So when I move it over, it becomes a divide by 3. So you're saying x is equal to minus 2 divided by 3. Okay, so they are your two answers here. X would be equal to minus 2/3. You could also write that as minus 0.6 reoccurring. And then x is equal to 5. Okay, so when you're factorising, up here, just basic factorising, it's just asking you to put it into brackets. But here, when you're factorising, it must equal 0 to then solve it. If it doesn't equal 0, make it equal 0 and go from there. So the next bit we'll look at is then how we actually solve these questions using the quadratic formula. So I'm going to just write the answers down. So we know the answers are x equals minus 9 or x equals 2 for that one. And we know that the answers for this one are x equals minus 2/3 or x equals 5. I'm just going to show you how to use a quadratic formula with these questions to solve them. I'm going to delete all this, and then we'll talk through what we do in a second. Okay, so we've spoken about that factorising part, so now we're going to talk about how we solve by using the quadratic formula. So if you're ever stuck and think you can't factorise a quadratic, you could always use a quadratic formula. It will work for any quadratic equation. Again, making sure it must equal 0. So let's go back to this question here. We know the answer should be -9. We know the answer should be 2. So let's just see what we get. Now, first of all, you need to know the quadratic formula, which is minus b plus or minus the square root of b squared minus 4ac all divided by 2a. And that basically will give you your value of x, okay? So really important that you know that. What you then do is you label each part of your equation. So this is a, this is b, and this is c. And what I'm actually talking about here is the number. So b would be 7, c would be -18, and a here is 1, okay? So then all it is a case of once you've labelled your equation correctly, it's a case of just substituting all of that into this formula. So let's go back to the formula. If we look here, it says minus b, and I'm telling you that a is 1, b is +7, and c is -18. So actually, it's worth making sure you write if they're positive or negative. So minus b, which means 7. So it's -7 is what I should be writing as the first part of my equation, plus or minus the square root. Now, what I'm actually going to do is I'm going to do the positive value first, okay? So instead of putting plus or minus, I'm going to just put plus. B is 7, so it's 7 squared. -4, always -4. And remember that 4ac means 4 times a, which is 1, times c, which is -18, all divided by 2 times 1, because a is 1. Now, some of these you'll be able to work out in your head, because when you actually do the square root, it will give you a number that can be square rooted. Some of them won't, so then you'll have to work it out, okay? But let's just see, work it out using the calculator. So let's just see what we end up getting. So -7 plus, I know that 7 squared is 49, and then -4, so I'm now doing this second part here. -4 times 1 is -4, and then times by -18. So you do -4 times -18, which would be -72. But instead of it being a negative, because you're doing -4 times -18, it becomes a positive. So that actually becomes 72. And then that's all divided by 2. Okay, so what I've just done there, 7 squared is 49, -4 times 1 is just -4, and then -4 times -18 gives you a positive 72. So at that point, what you're effectively doing is the square root of 72 plus 49. So let's put this back in. So -7 plus 49 plus 72 is 121, all divided by 2. That basically is, so the square root of 121 is 11. So you're actually doing -7 plus 11, all divided by 2. And hopefully you know that -7 plus 11 is 4. 4 divided by 2 is 2. So that's how I would get that value there. And then basically what you need to do is redo the whole thing again, but instead of putting a plus here, you now put a minus. So we write it again, -7, but now we put minus the square root of 7 squared -4 times 1 times -18, all divided by 2 times 1. And let's go back to what we know. We know that that square root is the square root of 121, and then all divided by 2. We know that becomes -7 minus 11 divided by 2. And this is therefore where it's different, because we're now doing -7 minus 11. So it's like saying it's -7 degrees outside and it gets 11 degrees colder. So therefore that gives me a total of -18, and -18 divided by 2 is -9. So that's how you end up getting both of those two values. Okay, now let's see what that looks like in this example, because there's something slightly different about this one, and we'll talk about that now. So the first thing we would have done is rearrange it. So 3x squared minus 13x minus 10 equals 0. Then we label it again. So we're doing our a value, which now is 3, our b value, which is minus 13, and our c value, which is minus 10. So a is equal to plus 3, b is equal to minus 13, and c is equal to minus 10. So really important that you have got those negatives in here, and I'll show you why. So what we're saying is minus b, which is the start of, if you look back at the quadratic formula, minus b is the start. So what we're saying is it's minus, but my b value is minus 13. So it's minus 13. Then we're doing plus, first of all, the square root. Now, if you type this into a calculator, if your b value is negative, you must always make sure to put it in brackets. So if you ever want, if you're just not sure and you want to, if you're using a calculator, back here, you could always put that brackets around that, and you could put brackets around that part as well. If it is positive or negative, it wouldn't matter. So if you want to just remember that, that's fine. But if you don't put the brackets around it on the calculator, then it'll end up giving you an incorrect answer. So then it's minus 4 times a, and a now is 3, times c, which is minus 10, all divided by 2 times a. 2 times a this time is 2 times 3. So let's look at what we actually end up having there. Now this becomes positive 13. So I actually have plus 13 here. Then let's work out, so we're then adding, let's work out this root sign. Minus 13 squared is actually positive 169, because it's minus 13 times minus 13, which gives you a positive. Minus 4 times 3 is minus 12. And then minus 12 times minus 10 will be positive 120. Okay, all divided by, that becomes 6. Okay, so that's your process for that first part. And the reason I do that is because actually you need to make sure that if your b value is negative, you put that in brackets there, and also this will become a positive at the start because it's minus minus. So let's look at what we got then. So actually what we end up having is 13 plus the square root of 289, all divided by 6. Now the square root of 289 is actually 17, so that works quite nicely. So we have 13 plus 17, all divided by 6. 13 plus 17 is 30. 30 divided by 6 is 5, which is how we end up getting that value there. Okay, and then let's just redo it again, making sure we know what we're doing. So instead of it being a plus here, I'm going to change that to a negative now. So it ends up being plus 13, so it's minus 13, minus the square root of 169 plus 120. So all of that stays the same. So we know that ends up giving us 289, all divided by 6. We know that that becomes 13. But this time we're doing minus 17 and then divided by 6. Well, 13 minus 17 will give you minus 4. Minus 4 divided by 6 simplifies because they both divide by 2. So it ends up giving you minus 2 over 3, which is how we end up with that answer there. Okay, so they're your two kind of key ways to solve a quadratic. First one, factorising, which we've just been through previously, and then that second one using the quadratic formula. Key thing with the quadratic formula is, first of all, remember the formula. So make sure you know this off by heart. And secondly, make sure that if your b value is a negative, like it is here, you put a double negative at the start so it turns it positive. And then when you're typing it on a calculator, you just remember it's got to be in brackets if you're typing it in the calculator. If you're not using the calculator, just remember minus 13 squared becomes a positive value here, positive 169. Okay. So the next thing, the next part of the video will be coming up next, but that's all your stuff that you need to be aware of about quadratics. So looking at this then, what we can see is some of this information that we've just done in context. You can see why quadratics are so important and why you need to know how to do them. So let's just read this question. It says the area of the rectangle is 28 centimeters squared. Find the perimeter. So understanding the context of what this is saying, it's talking about area. So in order to find the area of this shape, we're going to be doing the width times the length. Okay, so this being the width, this being the length. It's a rectangle. Obviously, if it was a triangle, we'd do base times height divided by 2. So just make sure you look at what shape it would potentially be. Ultimately, it's asking me to find the perimeter, which means I'm going to need to know the length of this side and the length of this side. And in order to do that, I'm going to need to know what x is. So that's what I need to do first of all. So to find the area of a rectangle, I'd multiply this side by this side. Well, let's do that. So 2x plus 4 multiplied by x minus 3 is basically what it's telling you to do. Now, I teach this as the moon method. So you're doing that times that, that times that, that times that, and that times that. So 2x times x is 2x squared. 2x times minus 3 is minus 6x. 4 times x is 4x. And 4 times minus 3 is minus 12. Let's tidy that up. So this becomes 2x squared minus 6x plus 4x is minus 2x minus 12. Now what I know is that when I do that, that side times that side gives me the area, and the area is 28 centimeters squared. So what you've just done is you've said, doesn't matter what this length is, it doesn't matter what this length is, when I times them together, I will get 28, and that's exactly what this part here says. So just remember, multiply both sides together, but because you're multiplying two values there and two values there, you have to do it as a moon method, and then collect your like terms. Okay, so 2x squared minus 2x minus 12, like we looked at in the previous part of the video, we need to make this equal 0 to solve it. So I take the 28 over, it becomes 2x squared minus 2x minus 12, and then minus 28 equals 0. So if we're talking about where you'd pick up marks in an exam, you'd pick up a mark for doing this or this, and your second mark would come from making it equal 0. Okay, so really important that you're showing the examiner you know how to solve a quadratic and that it must equal 0. So from here, let's tidy that up. So we end up with 2x squared minus 2x, and then minus 12 minus 28 is minus 40 equals 0. Now, this is quite nice to simplify, so the reason this is a little bit harder to factorise is because there's a 2x squared. However, each of these values can divide by 2, so actually I can just have a little bit of a shortcut here, divide it all by 2, and then I now just need to factorise and solve this equation instead. So we're looking at two numbers that add to minus 1 and multiply to minus 20. Again, depending on how confident you are with factorising, hopefully you can see that my two values would be 5 and 4. I just need to get the negatives the right way around. So it'd be minus 5 and plus 4, because minus 5 plus 4 is minus 1, and minus 5 times 4 is minus 20. So therefore I'm saying x minus 5 equals 0, or x plus 4 equals 0. So therefore x is equal to positive 5, because what I'm doing is I'm taking that 5 and moving it over here, and the plus 4 is going the other side as well. So this one would become x is equal to minus 4. So what I'm saying is, in this question, x is equal to 5 or x is equal to minus 4. Now I can't choose both of them. And the reason is because if I said x was minus 4, what I'm saying is this side is minus 4, minus 3. So I'm changing x for minus 4, because that's what it is there. Minus 4 minus 3 is minus 7. How can I have a length that is minus 7 centimeters? Okay, so basically when you end up solving these kind of questions that are to do with area, and there's also ones that come in about probability, you have to choose a positive value. So in this question, x has to be 5. Okay, so what I'm doing is I'm saying 5 minus 3 goes there, and then this becomes 2 times 5, and then plus 4. So 2 times 5 is 10, plus 4 is 14, 5 minus 3 is 2. So my sides become 14 and 2. This becomes 14. This becomes 2, because they have to be the same because it's a rectangle. It tells me in the question it's a rectangle. And then therefore, to find the perimeter, you just add all sides together, because perimeter is the outside, perimeter plus. And so you're doing 14 plus 14 plus 2 plus 2. So 28, 30, 32 centimeters would be the perimeter of this shape. Okay, so you can see a clear example of how to use solving quadratic in context to help you solve a problem. Okay, right, moving on to the next part of the video then. So in this next bit, we're going to talk about this concept of working backwards. Okay, we're going to look at a few different examples. And what I mean by working backwards is you've basically been given an answer to a question and it's asking you to work out a missing value. Now, this comes up in so many different areas. I'm just going to do a few here. So there's one here that we're going to do with volume. It would come up with a lot of trigonometry stuff, especially with things like the sine rule for area. It might give you the area and then ask you to find a missing side, but the concept will be exactly the same. It's always about writing down what you know and then rearranging it. Okay, so let's just go through a couple of examples. I'm going to do one here about cylinder, then I'm going to do another one about reverse percentage here, and then I'm going to do another one about compound percentage change. So just talk to you about how we kind of work backwards with this. Really, really important skill to have. As I say, it's definitely worth getting your head around this concept to do with loads of different areas. Okay, so let's read the question. It says the volume of the cylinder is 360 pi. So it's been left in terms of pi, so it could come up in paper 1. So it's 360 pi centimeters cubed. So let's go through what do I know. So whenever you see a question like this, which is giving you an answer, write down what do I know. Okay, what pieces of information do I know? Well, this is to do with volume. Okay, so to find the volume of any shape, you find the area of the top in this case, or it could also be the front, depending on what way round it is. And the reason I say that is because if the cylinder was drawn this way round, if it looked a bit like that, excuse the dodgy drawing, but if it looked like that, like it was laying on its side, that would be the front. But where it's drawn this way round, the area of the top is what we're going to be looking for, okay? So it's the area of the top or the front, and then it's times by the depth, or in this case, the height, okay? Now that will work for any shape. So for example, if we had a triangular prism like this, you'd find the area of the front, so area of a triangle base times height divided by 2, and then you times it by how far back it goes, okay? So it's worth getting your head around area of shapes. You'd also see it written online elsewhere as area of the cross section, and the cross section is basically what I'm saying there. It's that top shape. So that shape is a circle. So how do I find the area of a circle? Well, the answer is pi times the radius squared. So that's the area of the top or the front, and then times it by the depth, times by the height, in this case, because it's not the depth, it's the height, is equal to area. So what do I know? Well, I know I've got to use pi r squared, I know I've got to times it by the height, and I know the area. So now what you need to do is you just need to substitute in what you know. Okay, well, I know pi, I know the radius, but I don't know the height, and I know the area. Okay, so that's what I know. Then say to yourself, what am I trying to find? So what am I finding? And the answer in this case is the height. Okay, so underline that bit. That's what I'm trying to find. So because you're finding that bit, what you then need to do is basically get it on its own. So it's about rearranging. So this is why algebra is so important in maths. I take that now and move it over the other side because I need to isolate the h. And because I'm taking that over, it now becomes a divide. Okay, so what I'm saying is the height is equal to 360 pi divided by, well, 6 squared is 36. So then 36 pi. Okay, so this is why this is really important as well that you understand in terms of pi, because it could come up in a paper 1. So I'm saying 360 pi divided by 36 pi. Well, the pi divided by pi is just 1. So it actually gives you 1, but you can say it cancels it out. And then all I'm doing is 360 divided by 36. So therefore the answer there would be 10. Okay, so my height is actually 10 centimeters. Okay, so again, these are your two questions you should always ask yourself. What do I know? Well, this is what I know. And what am I finding? This is what I'm finding. And then when you're trying to find that, move the other things away from it. So let's look at this next example now, which is to do with reverse percentages, okay? So really common question. It gives you an answer. It tells me how much the TV was when it got reduced. And it's asking me to find the original price. So let's just quickly read it. In a sale, prices are reduced by 12%. So I'm underlining, looking at key pieces of information. The sale price of the TV is £492.80. What was the original price? Okay, so again, what do I know? So I know that it's had 12% off. It's been reduced by 12%. So that's 100 minus 12, which means it's now worth 88%. Okay, or as a single multiplier, that's 0.88. If you're not 100% sure about single multipliers, it's worth watching my video. I'll put a link to that in the description as well, on all these different areas that we've gone through, so you can watch ones in more detail if you're not 100% sure. So that's what I know so far. I do know how much it's now been reduced by. So let's form an equation here again. Let's move this to the side. Form an equation. Do I know how much it started? No. So I can call that x. That's the original price. What I do know is it's been multiplied by the single multiplier of 0.88. And when it's been reduced by 12% or times by 0.88, it ends up giving me £492.80. So this is what I know, okay? The second question I said to you is, what am I finding? So what am I finding? Well, I'm finding x here, right? So because I'm finding x, I take this over the other side, and it becomes a divide by 0.88. So x is equal to £492.80 divided by 0.88. And basically, this would be on a calculator paper, this one, I'd imagine. So you're doing 492.8 divided by 0.88, and it gives you 560. So the original price of the TV is £560. Now, a common mistake here is that people find 12% of this value. So they find 12% of £492.80 and then just add it on. That's incorrect, because this is a reverse percentage question. So it's working backwards. There is a second way you could do this. Okay, we could use this 88% over here. So this concept here, you could say, right, well, 88% is equal to £492.80. That's what I know. And the reason it's 88% is because it's had 12% off. So what you need to do is try and get this to 100, okay? Because 100% is the full price. Well, I can't get 88 to 100 very easily. So what I can do is get it to 1% by dividing by 88. And we know that the answer is obviously going to be 560. So if I that 1% would be £5.60. So that would be me doing £492.80 divided by 88. And then you just times your answer by 100 there to end up giving me £560. Okay, so that's the second way you could do it. But the concept's the same, right? What do I know? That's what I know. What am I trying to find? 100%. And then how do you get there? So always multiple methods, always multiple ways to do stuff in maths, but just always give yourself these two questions when you see working backwards, right? What do I know? What am I trying to find? Okay, so let's look at another example now. So the next one here is, again, a reverse working backwards concept, an idea of we've been given an answer, we need to work backwards. So let's just read it. £16,000 is placed in an account and it pays X%. So let's just circle some key pieces of information. Compound interest, that's really important. It's talking about compound interest. After 8 years, it is worth £19,494.45. Work out the value of X. So same thing. What do I know? So I know the original amount, okay? And if we're talking about compound interest, this is what you should be thinking about. So the original amount times by a single multiplier, and to the number of years will give you the final value, okay? So with compound interest, that's your formula that you want to be thinking about. Again, if you need a little bit of recap on compound interest and compound decay, it's worth watching my video I've done on that. So 16,000, what do I know? I know 16,000 is my original amount. Okay, so I've dealt with that bit. Single multiplier. Well, this is this part here. It's X%. So I know it's going up. So it's going to be 1 point something, okay, as a single multiplier. So I can just call it X% for now. And it's to the power of 8. So I know I'm going to do a power of 8 there. And that's equal to my final value, £19,494.45. Okay. So this is what I know. Okay. We're going back to what do I know? That's what I know. What am I trying to find is the next question. Well, I'm trying to find this. So again, this has to go across. And this will also need to be removed, but because it's an indice, we're going to leave it till last. So X% to the power of 8 is equal to £19,494.45. And this time we are dividing, because that's 16,000 times we're dividing by 16,000. Okay, I'm going to get the calculator up now on the split screen so you can see exactly the sum that I'm going to do and how this is going to work, okay? Okay, so here we are back now. So we've got the £19,494.45p. So on the right-hand side here, I've just got the Desmos calculator up. It's a nice one to use if you don't have a scientific calculator at home. So I've opened a fraction button. So £19,494.45p. And that's divided by 16,000. Now, it's really important that we've got to remember the fact that that's X%. So I'm still going to think about the single multiplier because I'm keeping that in percent at the moment. But that gives me 1.21840. Notice I'm not rounding it. 3125. The reason I'm not rounding it is because I'm going to need to use that number again. This is to the power of 8 because it's 8 years. So to remove the power of 8, you're going to need to take the 8th root. So the X% will be the 8th root of 1.218403.125. So on your calculator again, you can, here you can see on the Desmos, there's the n with the root. I'm going to put the 8th root and then I'm going to type that number in there, 1.218403.125. So the 8th root of that gives me, as you can see there on the screen, 1.025, and you can see because there's loads of zeros there, I can stop. There's 1, 2, 3, 4 zeros, 2, 4. So because that number is very, very close to 1.025, I can leave my answer like that. Now, that's not my final answer. That is your single multiplier. This is a really common question. It does come up. Single multiplier means that that is not your final answer. So X is not 1.025%. What you need to remember is when you're talking about compound interest, it's 100 plus whatever the number is will give you a number. So let's say, for example, if this was 5%, it'd be 100 plus 5, which is 105, and divide it by 100 to get your single multiplier, 1.05. So if I told you that that was 5%, this is how I would work it out. So I'd do 100 plus 5 and then divide it by 100 to get 1.05. So what I'm now saying, so it's kind of working backwards again, I'm saying 100 plus something gives me 1025. And then when I divide that, 102.5, and then when I divide that by 100, I get 1.025 because this is my single multiplier, okay? Well, basically what you've got to figure out to yourself is what do I need to add to 100 to get 102.5? And the answer is 2.5. So in this question here, X is equal to 2.5%. Okay, that's what my original percentage would have been in this question. And that's why it's really important that you don't put your answer as 1.025. So there's almost two elements of working backwards there. First bit here, we've got to rearrange all this. And then we're working backwards with this single multiplier here to figure out the initial percentage. Okay, same process. What do I know? This is everything I know. What am I trying to find? X. So go back to that process on how you find it. Okay, there are lots more areas of working backwards, so many more different styles of question. So it is really important that you get your head around that idea of working backwards. If you've been given a question where there's an answer involved, it's already given you the answer, work backwards to figure out how you find it. Okay, so moving on to the next part of the video, we're just going to go through a few more fundamentals of the higher paper and things that you need to know. Okay, so looking at this next bit, we're going to start talking about some ratio problems, a couple of just basic elements, and then we'll start looking at a slightly more complex one. Ratio is really common, does come up a lot within the higher papers. It's something you need to get your head around. Okay, so let's read this. We've got Amy, Bill, and Chris share some money in the ratio 5, 8, 11. So Amy, Bill, and Chris, I'm going to write it this way, share some money in the ratio 5, 8, 11. So just write down your key pieces of information. Now the reason this question is slightly harder is because it says Chris gets £27 more than Billy. So we're talking about these two ratios, right? The difference between those two ratios is £27. So if you've got a question that says more than or less than, this is the way you'd approach that ratio question. So where Chris is getting £27 more than Billy, you basically need to work out how much was shared in total. So I need to find out how much Amy gets, how much Billy gets, and how much Chris gets, because we know that the total is X, right? We don't know how much money it is. But what I do know, in any ratio question, you're going to be looking at finding one ratio. So if we can find one ratio first, that's going to help us answer it. So let's look at what we know here. So again, thinking about this concept of what do we know, what we're trying to find from the working backwards stuff we spoke about. The difference here is 3. The difference between 8 and 11 is 3 ratios. So I know that 3 ratios is equal to a total of £27. That's really important because now you can be in a position where you can find one ratio. So divide that by 3. So therefore I divide that by 3. And that tells me that one ratio is £9. Okay, that would get you a mark because in ratio questions, trying to find one ratio or one part will get you a mark. So now all I need to do is take that information, go back to here, 5 ratios there, so 5 times 9, which means Amy gets a total of £45. Then we go to the next one, so it's 8 ratios times by 9, which would be £72. And then the last one is 11 times 9, which is £99. Double check that you're right, because what we know is the difference between these two should therefore be 27, well the difference between 72 and 99 is £27. So I know my answer is correct. Okay, so that's an example of a ratio question where you have more than. You could also see it where someone has less than, and you don't know the actual total to start with. Okay, so really important that you get your head around that. So the next style we're going to look at is ratio where there's an overlap. If you're not 100% sure on ratio, I've done a video on ratio as well, which is linked to in the description, so you can spend a bit of time looking just at purely ratio stuff if it's something you need to work on. But let's look at this example here. So we've got cats, dogs, and rabbits. So we've got 3 parts. The ratio of cats to dogs is 5:3. So let's just write down what we've got. We've got cats, dogs, rabbits. Cats to dogs is 5:3. And then dogs to rabbits is 2:13. So dogs to rabbits is 2:13. So this is actually what we've got. Now, I like to call this ratio with an overlap, okay? Now, the reason I say ratio with an overlap is because we have this overlap section here where dog shows up in this ratio, but also in this ratio. Now, there's 2 ways you can answer this question. If you have ratio with an overlap, the first way you can do it is you need to make the overlap the same, okay? So we need to make this the same number. Make the same number, okay? So 3 and 2, what I need to do is make them both the same number. So it's a bit like fractions. Well, if I times that by 2 and that one by 3, they both become 6. So my new ratio, cats, dogs, rabbits, times it all by 2. So 5 times 2 is 10. The dogs times 2 becomes 6. And then the one underneath, I'm timesing it by 3. So you can see now that dogs become 6. And then 13 times by 3 is 39. Okay. Now what basically happens is, because this is now the same as this, we can just pop that ratio up the top there. And my ratio is now relative. It becomes cats to dogs to rabbits is 10 to 6 to 39. Now it's important that you understand how to do it this way, because sometimes it might just ask you for the ratio of cats to dogs to rabbits in its simplest form. And that's how you would do it. But this question is then saying to me there are a total of 78 rabbits. So I know that this is equal to 78. And then it says how many cats are there in the shop. So this is what I'm being asked to find, okay? Right, well, again, let's go back to that concept. Concept of ratio means you've got to find one ratio, okay? Now, I don't know what one ratio is, but I do know that 39 ratios is equal to 78, okay? So 39 is equal to 78. I need to make it to 1, so I divide by 39. So therefore, you're doing 78 divided by 39. And when you do 38 divided by 79, when you do 78 divided by 39, you get 2. So one ratio is equal to 2. Okay, 39 goes into 78 twice. So we just picked up another mark there. We'd pick up a mark for making these ratios the same as well. Because I now know that one ratio is 2, let's go back to the question. How many cats are there in the shop? Well, there's 10 ratios for cats. So you're just doing 10 times by 2, and your answer would be 20. If it asked me for dogs, dogs would be 6 times 2, which is 12. And we already know there's 78 there. So if it asked me for the total number of animals as well, I would just add all those together. Okay, so that's the first way you could do it. The second way you could do it is a little bit different. So let's just get rid of that and get rid of that, and we'll start again. The second way you could do it is you could go and write down what you know. So we still got cats, dogs, rabbits. We know it's 5:3, and we know it's 2:13. So this and this is what I'm going to look at first of all. So I know that there are 78 rabbits. So what I could do is ignore this top part, first of all. So I'm going to ignore this, and I'm going to just deal with this part. So it tells me that there are 78 rabbits, and that's equal to 13 ratios. So you could say 13 ratios is equal to 78. And again, you still want to find one ratio. So you divide that by 13. And so you divide this by 13 as well. So if you do 78 divided by 13, you get an answer of 6. So one ratio becomes 6. Let's go back to this. I then times that by 6. So I still get my answer of 12 dogs. So I know that there are 12 dogs. Now, I now have to then go to this top ratio here. And I know that that 3 is equal to 12 dogs. Okay, so 3 ratios is equal to 12 dogs because I've worked out the 12 down here, which means one ratio, so divide by 3, divide this by 3, is 4. So one ratio would be 4 dogs, and then because I know one ratio is 4 there, I just do the 5 times 4, and that gives me 20. So that's the second way you could do it as well. Okay, so there's 2 ways to do it. You can do it as 2 separate things. So I work out the first bit there, find one ratio by working this out here, and then now I know what one ratio is, I times that by 2 to get the total number of dogs, and then that value there has to be the same here. So I substitute it in there and say 3 ratios is equal to 12, and then find your number of cats from there. Okay, so there's 2 different ways to answer that. I prefer the first way, because actually this question might just say to you in an exam, it might say find the ratio of C to D to R in its simplest form, in which case you need to then make these both to 6 like we spoke about. Okay, right, final bit we're going to look at then is a slightly more complex ratio question, but it involves some fraction work. Okay, so this bit here, it says work out the fraction of all shapes that are small. So this would be one of the last questions in the paper, but if you see a ratio question that is actually talking about fractions, the first thing you want to do is turn everything into a fraction. So this is where understanding that you can turn fractions to ratios and ratios to fractions is really important. So if we look at this, I've got green, there are green and purple cubes in a bag in the ratio of 6 to 5. So that's 6 and the purple is 5. The first thing I'm going to do then before reading the rest of this question is turn that into a fraction. So green is 6 parts, but out of the total, which means 6 plus 5 is 11, and purple is 5 out of 11. Okay, so I'm saying that in this bag, 6 out of 11 parts are green, 5 out of 11 parts are purple. So because the question is to do with fractions, and it's a ratio question, I've just turned them to fractions. It then says of the green cube, so I'm now talking about this one here. So of the green, large to small, so large to small is 2 to 3. Okay, so again, let's turn those to fractions. So that becomes 2 out of 5 now, because 2 plus 3 is 5, and that becomes 3 over 5. Okay, so 3/5 of all the green cubes are small, and 2/5 of all the large cubes, 2/5 of all the green cubes are large. We do the same on the purple side. It says of the purple cubes, the ratio of large, so again, making sure you're writing it the right way round, large to small is 3 to 5. So this now becomes over 8, because 3 plus 5 gives you 8. Right, so now I've actually picked up a mark here because I converted everything to fractions. So if you're just looking at picking up one mark or a couple of marks, do that first. Now what we need to do is just think about what the question is asking me to do. It says work out the fraction of all shapes that are small. So I'm only looking at the small part. So small here of the green, and small here, and small here of the purple. Now, this is a very similar concept to probability. What you do is you multiply those fractions together, because what I'm saying is 3/5 of 6/11 are small green. 5/8 of the 5/11 are purple that are small. So let's work that out. I'm saying 6 over 11 times by 3 over 5. So that's my green. And then what I'm saying is 5 over 11 times 5 over 8 is my purple. So that becomes 25 over 88. And the green would become 18 over 55. So 3/5 of 6/11 is that bit. And then 5/8 of 5/11 is that bit. What you then need to do, finally, is just add those two answers together. So it becomes 18 over 55 plus 25 over 88. Now, if this came up in a paper 1, you would do it where you'd make the denominators the same. Obviously, if it comes up in a paper 2 or paper 3, you can use a calculator to work out this sum. But if I needed to make the denominators the same, the lowest common multiple of these two would be 440. So I'd need to think about, I think that's times by 8 to get that to 440, and that'd be times by 5 to get that to 440. Okay, so if you wanted to do it the long way round, where you're making the denominators the same, I'd do 18 times by 8, which is 144. And then that becomes over 440, because 55 times by 8 is 440. And the other one, I'm going to times it by 5, so 25 times by 5 is 125 over 440. Then you're adding those together, which would end up giving you, so you're doing 125 plus 144 to get 269 as your numerator, and then 440 would be a denominator. So that's the fraction of all shapes that would be small. Okay, so as I say, it's not the easiest thing to find the lowest common multiple there. The question that you might have in an exam would be a little bit easier to find the lowest common multiple of those two numbers. Or, as I say, if it comes up in a paper 2 or paper 3, you could just type that into your calculator. Okay, so use that method whenever you see a ratio question that is talking then about fractions. You've got your overlap question there, and you've got a more than or a less than question there. So they're the slightly harder ratio questions that you might see come up, but that's how you'd pick up marks in them. Okay, so moving on now to the next part of the video. Okay, so in this bit we're going to talk about product of prime factors, highest common factor, lowest common multiple, making sure you're happy with this concept as well. Okay, so if it says express 48 as a product of its prime factors, so if you see this product of its prime factors, it's asking you to do a prime factor tree. Okay, so just remember this. Product of its prime factors means prime factor tree. So you put 48 and you're basically looking at what numbers multiply. Always about multiplying, it's not adding. What multiplies to give you 48. Now I'd go 12 and 4. You could have used 24 and 2. I'd always try and choose a couple of numbers that are quite close together just to make it a little bit easier, but it doesn't matter. So 12 breaks down to 4 and 3. Circle your prime number. 4 breaks down to 2 and 2. And 4 breaks down to 2 and 2. So just double check your prime factor tree, right? Once you've done it, just go through it in your head. 2 times 2 is 4. 4 times 3 is 12. 12 times 2 is 24, and 24 times 2 is 48. So when you multiply them, it should give you the number that you originally started with. So you can then say 48 is equal to 2 times 2 times 2 times 2 times 3, and almost tick them off. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Or if it asks you to write in index notation or index form, it's 2 to the power 4 times 3. Okay, so really important that you remember that. Don't put a comma. So this is a really common mistake. Pupils put that, or pupils do this and they put +3. Okay, make sure you are putting times between your numbers there. Okay, so now let's look at this next question here. It then says find the highest common factor and the lowest common multiple of 80 and 48. Now we've just done 48 here. We've got the prime factors written out. So what I'm going to do is I'm going to show you the way how you can find the highest common factor and lowest common multiple by using prime factor tree. So I'm just going to quickly do 80. So I've already done 48. Okay, that's what I've got on that left-hand side over here. I'm going to now do 80. So 80 is broken down to 8 and 10, 4 and 2, 5 and 2, they're all primes, and 4 is broken down to 2 and 2. So what you then do is, now I've got all these, so 80 I'm going to rewrite as 2 times 2 times 2 times 2, so 1, 2, 3, 4 times 5. What you then do is you draw a Venn diagram. So I put my two circles, and I'm going to label it 48 and 80. Okay, so from this point, what I need to now start to do is to see what matches up in both of these lists. So the two lists I'm concerned with are this one and what we've got here, because these are my two numbers, so 48 and 80. So if you're asked about highest common factor or lowest common multiple, do your prime factor tree first of all. So I've done the prime factor tree already for 48, do the prime factor tree for 80, that's what I've got there. What you're now going to do is you're basically, using this Venn diagram, we're going to play a game of snap, right? So what is in both lists? Well, there's a 2 there and there's a 2 there. So because there's a 2 in both, you stick a 2 in the middle. There's also a 2 there and a 2 there, so we stick another 2 in the middle. Another 2, so there's another 2 in the middle. And then there's finally another 2 in the middle. So you can see all the things that match up, so that's what I'm saying, playing that game of snap, go in the middle. Then what you need to do is see what's left over. Well, I can see here there's a 3 left over for that 48, so 3 goes there. And here there's a 5 left over for the 80. Okay, so using a Venn diagram, it allows you to organize information. Prime factor trees are pretty quick to do. This is the bit you need to remember. You need to remember that the middle section here, so the overlap, the 2, 2, 2, and 2, will give you your highest common factor. So just this part here, when you multiply these numbers together, that will give you your highest common factor. So you're doing 2 times 2 times 2 times 2. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So your highest common factor in this question is 16. That is the highest number that goes into 48 and into 80. Now you might have been able to work that out with a different method, but if you have larger numbers and it becomes a little bit harder to do because the numbers are bigger, this is just a nice way to do it. The next thing it's asking you to find is lowest common multiple. Okay, so the lowest common multiple is not the middle section. Think about it in the fact that a lowest common multiple is a multiple, meaning it gets bigger. So therefore you have to multiply all the numbers in the Venn diagram. So if I start from this left-hand side, I'm going to do 3 times 2 times 2 times 2 times 2 times 5. Okay, now you could kind of cheat because you already know the middle section gives you 16. So then you're doing 16 times 3 times 5. Or if you wanted to do it each step by step, so 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48, and then you're doing 48 times 5. So again, if you're not 100% sure, you could use the column method. 48 times 5, so 5 8s are 40. 5 times 4 is 20, 240. Okay, so that would be how you would find your lowest common multiple. Okay, so just remember, highest common factor is just the middle part of your Venn diagram, and lowest common multiple, all the values in the Venn diagram. It's just important to get your Venn diagram correct. So let's just look at one more example here, and then we've come to the end of our fundamental parts for the higher. Just look at a slightly different style here. So it's told you this is A. So A is 2 to the power of 2 times 3 times 5, and B is 2 times 3 to the power of 2 times 5 times 7. Now, if you wanted to, you could multiply all of this out and figure out what A is. You could actually figure out that A is this particular number. However, you don't need to. So let's just go through the process we've just done. Okay, if you wanted to pause the video and have a go at doing this yourself, you could, but I'm going to go through it now. I'm just going to rewrite A out and B out over here. And instead of putting the power, I'm going to write 2 times 2 times 3 times 5. And I'm going to write out B as 2 times 3 times 3 times 5 times 7. Okay, the reason I'm doing that is because if there's a power involved, you might forget that there's 2 of them. Just in case there's 2 values that match up, you need to write it out in full. It might help you. So we're going back to snap. So there's a 2 in both, so 2 goes in the middle. There's a 3 in both, so 3 goes in the middle. And there's also a 5 in both, so 5 goes into the middle. So there's no other values that match up. That's my game of snap. That's the middle section to find the highest common factor. And then you're basically just figuring out what goes in the other bits. So 2 is left over for A. We've got a 3 and a 7 left over for B. So that's your Venn diagram complete. So now we need to find the highest common factor. So the highest common factor is going to be this middle section here. So I'm just going to do 2 times 3 times 5. 2 times 3 is 6. 6 times 5 is 30. So the highest common factor of those two numbers would be 30. And then for lowest common multiple, remember, as we said, what we're now looking at is we're looking at everything there, and everything there being multiplied together. So we go from left to right, that's 2 times 2 times 3 times 5, so that, and that, times 3 times 7. Okay, well 2 times 2 is 4, times that by 3 is 12, 12 times 5 is 60, 60 times 3 is 180, and then you're doing 180 times by 7 as your final step. So 7 times 0 is 0, 7 times 8 is 56, 7 times 1 is 7, add on your 5, 8, 9, 10, 11, 12, so 1260 is your lowest common multiple for these two numbers. And as you can see, that's why it's really important to get your head around how to do lowest common multiple with a Venn diagram, because you actually don't know what the numbers are. It's just told you the two numbers based on their prime factor decomposition already, and that's what that is. That's prime factor decomposition. Okay, so we've been through a lot of stuff there in this video. It is by no means an exhaustive list of everything you need to know for hire. It's just some of the fundamental things that if you know how to do, it will help you pick up marks along the way. I can't stress the importance enough about the quadratic elements and the surd stuff. It will help you pick up additional marks. Algebra makes up a massive part of the hire paper, so do make sure you've looked through those algebra videos and you're really happy and content with how to work through your algebra stuff, okay? I hope you found it useful, hope it helps you, and good luck in any of your exams. I'll see you all in the next video.